Now we'll be seeing how to solve the goal programming formulation we have done. Mm, it is solved by simplex method. Very first, the objective function we had in goal programming problem was minimization type. We usually convert it into maximization type by changing the coefficients of all the variables from positive to negative or negative to positive, simply by changing the coefficients of all the variables, right? Now you may wonder what we have to do with the coefficients P1, P2, P3 we have taken in the formulation, particularly in the objective function. Okay, you have to retain those coefficients as those are. Now you will be seeing the formulation, all right. Mm, Here you see the coefficient of x1, x2, y1, y2 in our formulation is 0. Coefficients of these variables in objective function are 0. These variables do not exist in objective function, right? D1 minus, D2 minus, and D3 plus was having coefficient P1. Because we have to convert our objective function from minimize to maximize, we have turned them to negative. Then the coefficient of D4 plus was P2 and coefficient of D5 minus was P3. We converted it to minus P2 and minus P3 respectively. Rest other coefficients are zero because they do not exist in the objective function. So very first in the top row you have to write the variables of your interest, and then underachievement, overachievement variables we have taken for each of the constraint or the goal. Then their corresponding coefficients in all the constraints we have written here. The method is exactly the same as simplex method. It is simplex method in fact, with little bit of modifications done in that, right? And those modifications are towards achieving the goals in the sequence they are given, right? So all the coefficients of the variables are written here. Now here you have to write here you have to write the basic variables. See here, first basic variable is d1 minus because it satisfies the condition of becoming the basic variable. Second is d2 minus. Third is d3 minus. Okay, and fourth is d4 minus. All right. Mm, Fourth is d4 minus. It could have been fifth is d5 minus. Okay, and the coefficients of d1 minus, d2 minus are respectively minus p1, minus p1, d3 minus, and d4 minus have coefficients 0, coefficient 0, and d5 minus has coefficient minus p3. All right. Then we have found out Cj minus Ej, and lastly value of Z. The way for finding Cj minus Ej and Z are is same. That's why in one go we have found that out. And now we find that the maximum positive Cj minus Ej is either for x2 or for y2. You can take any of these two as entering variable. Mhm. As entering variable, right? So as entering variable, therefore you will be taking this as a key column, then replacement ratio, right? It is the ratio of b by key, right? So here I get minimum replacement ratio for D5 minus, and that happens to be the key row, and this is the key element, right? Then in the second iteration we want to make this column 0, 0, 0, 0, and 1. All right. x2 column, and that we have made by doing the transformation on the rows. For example, this fifth row I have divided throughout by 8, and then this fourth row and first row are retained, and by using the formula you are used to with, well, for example, for getting 0 here, it will be R2 minus R5 modified from here. That will get you 0 here. Then for getting 0 here, it will be R3 minus 3 times this row will get you 0 here. That's how we transform. Okay, and we get whole this simplex table, and here once again we find cj minus ej. This is 0.125 p1, this is 0.125 p1, this minus p1, in between there are zeros. All right, and lastly that is 0.125 p1, right? Now uh, the condition which is very important for taking the entering variable is that first of all p1's coefficient should be seen it if it exists anywhere, and if it is negative then that won't happen to be the entering variable, right? If p1 doesn't exist, then coefficients of P2 will be seen. Okay. If it has positive coefficient, whatever be the coefficient of P3 and other priorities, may it be positive, may it be negative, but if P2 is positive and P1 doesn't exist as a positive coefficient anywhere in Cj minus Ej row in the concerned iteration, then that won't be the entering variable, right? If P1 has negative coefficient, P2 has positive coefficient, then that particular variable won't be entering variable. After making sure that all P1s in Cj minus Ej row are negative, then you want to look for the column in which coefficient of P2 is positive, right? Coefficient of P2 is positive maximum, and then that corresponding variable will be entering variable. Then after having all P2s everywhere in the rows negative, then you have to search for a column wherein you have P3 positive and maximum. This is the only change you have to um, look for while solving the goal programming problem. Here now when we see that P1 has coefficient 0.125 here, 0.125 here, 0.125 here, then you can take either this or this or this as entering variable. I have taken this as entering variable, then I have found out replacement ratio which comes minimum for D3, so D3 will be replaced by X1. All right. With that information, we proceed to the next iteration, right? Um, we proceed to the next iteration. Here it is, right? D3 replaced by X1. Okay, now the composition of basic variable is D1 minus D2 minus X1, D4 minus and X2. Okay, by doing all the transformations so as to qualify x1 as a basic variable, that will transform whole the simplex table. And after doing that, we once again find Cj minus Ej, and here I find for P1 has the coefficient 0.3636 for variable y1, It is 0.2727 for variable y2, and here it is negative for d2 plus negative. Here also negative coefficient for p1, negative coefficient for p1. Here negative for p1. Then you don't have to look for what is the coefficient for another priority like p2 or p3. Once coefficient for p1 is negative, then that doesn't qualify, that column doesn't qualify, that variable doesn't qualify to give you the entering variable. This coefficient is 0.0909. So amongst all this is maximum positive. So this will become entering variable. All right. After this becomes entering variable, we once again find replacement ratio. Replacement ratios are not to be taken when the key column has negative or zero entry. So here all these values are zero, and minimum replacement ratio I get for variable x2. So x2 will be living variable and y1 will be entering. So with that information, by after doing all the transformations, we once again find Cj minus Ej. So here 0 for x1, for x2 negative, for y1 0, for y2 negative, then for d1 minus 0, for d1 plus minus p1. Here 0, then negative 0, negative 0, negative p2, here negative p1. Here it is positive. So what is happening? D5 plus is entering variable, and then once again we find the replacement ratio, and we can find it only for the first row corresponding to variable d1 minus, and that comes 10. So d1 minus will get replaced by d5 plus. All right. So with that information, we carry out all the transformation process, and here we get that, right? All the transformation process. So d1 minus is replaced by d5 plus, and d5 plus we are making it qualify to be a basic variable. So all the transformation will go on, and um, once again you find Cj minus Ej. So here it is 0, here P1. Now earlier this had negative value of Cj minus Ej. Now it has converted to positive. Okay. Here also P1, here minus P1, minus P1, then minus P2, minus P3, and so on. And this is the value of Z, which is now coming to minus 40 P1. Okay, you don't forget to change the coefficients also. Now you will be taking the replacement ratio, and that comes equal to 40. 40 divided by the key column. I have taken y2 variable as the entering variable. I could have taken this as entering variable, but I saw that I will have to do many calculations, and here only one row is to be transformed. So I prefer taking this. But you can, or the computer can take this as entering variable. So mm, uh, after doing all the transformation, finally this is the iteration, this is the table I'm getting, and what I'm finding, that all Cj minus Ej's are now particularly all P1s have negative coefficient. Then I search for a column wherein P2 has positive coefficient. So no, I don't get P2 with positive coefficient. Had it been, I would have taken that as entering variable. Once after seeing and making sure that all P2s also have a negative coefficient, then I have searched for any P3, any variable in which P3 has positive coefficient. I don't have P3 as positive coefficient. So here I have got the optimal solution. All goals satisfied. Now what is the solution? Solution says that x1 will be 22.5. That means the number of products produced in assembled in regular time are 22.5, right? And in word time, those are 7.5. In regular time, 22.5, and overtime 7.5, and there is a demand of 30, which is made by regular time production and overtime production. Now 22.5, now for assembling one unit of A, it takes 4 hours, right? 22.5 multiplied by 4 will be 90, and complete regular hours are exhausted just by producing 22.5 units of A. So it is obvious that B should be produced in overtime, and we are getting Y2 equal to 40, and that was the demand for product B, that is produced in overtime. All right, and then the demand is satisfied, demand goal is satisfied, and the now what is this D4 minus? Now see, uh, the overtime I want to minimize, right? Overtime. Now, what is the overtime? It is overtime means 40 units of B. 40 units of B taking 3 hours each means 120 hours, and 7.5 units of A, each taking 4 hours. So 7.5 multiplied by 4 will be 30. 120 plus 30, 150. We can mm, we can minimize the overtime to that extent only. So D4 minus is 150, and last goal was the profit. Okay, we want to make it as maximum as possible. All right. So just see here D5 plus. Okay, so we wanted to see that value of D5 plus should come much more than that's 200. Okay, now see what is the profit we are going to get by producing um, some units of A, and how many we are producing? 40 units of A and 30 units of B. What is the profit? If you look at profit per unit, uh, 7 rupees per unit of A and 8 rupees per unit of B. So we are producing all in all how many? 40 units, 30 units of A, 30 units of A. So 30 into 7, 210, and 40 into 8, 320, means 530 units we are producing. Okay, we had the target of 200, so we are 330 plus the target. This is how I have just explained this to make you able to interpret the results. Okay, right? So this is how the goal programming problems are solved. Here all the goals were easily achievable. The problem would have been, you would have sensed the significance of goal programming, if suppose say you would have limited the overtime to something like 120. Okay, here we are having 90 regular hours and 150 overtime hours, so whole of our production is getting managed in a regular time and overtime. But suppose say we would have had our overtime limited to something like 120 or 100, then solving this would make you understand goal programming even better. All right, so we'll stop here. You try solving this problem with the goal on overtime of 120. Thanks a lot. Thank you very much.